Right, so we have voltage here equals 25 sine 50 pi t volts. Determine using integration the mean value over that range. Each correct 4 significant figures. What does that mean, each correct 4 significant figures? Anyway, I'm inclined to do the root mean square thing here with this, so what we're going to do, just for handiness sake, we're going to call this y instead of v. Y equals 25 sine 50 pi t, and then we're going to get y squared. So y squared equals the square of everything on the right hand side, so that's going to be 25 squared times sine 50 pi t, all to be squared, and it goes in here like that. Now this sine squared 50 pi t, we have a substitution we can use for that, and it's on the exam papers. Dig it up here. See here where we see sine squared x equals a half times 1 minus cos 2x. Right, so we can copy that in here. Sine squared x equals a half times, equals what? Yeah, a half times 1 minus cos 2x. Right? And in our situation here, we don't have sine squared x, we have sine squared 50 pi t. Right? So we're going to simplify this. 25 squared comes to 625. And sine squared 50 pi t, well, this is like our x here. So that becomes, this whole thing here becomes 1/2 outside of, again, 1 minus cos. It's not going to be 2 times x, it's going to be 2 times 50 pi t. Right, 50 pi t is like our x equivalent here. 2 times this structure will give us twice this, which will be 100. So we'll have 100 pi t. And another bracket like this. So we can bring the half outside and divide 6, or multiply a half by 625, which is the same as dividing 625 by 2. 625 multiplied by 1, 625 multiplied by a half, we get 312. So we have 312.5 outside of 1 minus cos 100 pi t. And that's y squared. And what we want to do is integrate y squared. We want to get the average. So to get the average value of y squared, in the limit set there, we're going to have 1 over 20 minus 0. Integrate over those limits, 20 on top, 0 down here, and we'll be integrating 312.5 times 1 minus cos 100 pi t. Right? We can take, this is just going to be 1 over 20 here, and we can take the 312 outside. So we can rewrite that as 312.5 over 20 times our integral 20, 0, and we have 1 minus cos 100 pi t. Right? 312 divided by 20 gives us 15.625. So this gives us 15.625. And then we're going to integrate this guy here, and we will get 1 will become t, and this structure here will become minus sine 100 pi t over 100 pi. Right, and we keep our limits 20 and 0 here. We're going to apply them now in a minute. I'll just change the colour. Right, so starting again up here, we're going to have 15.625 times, we have a double bracket, 20 minus sine 2000, which will be 2000 pi over 100 pi minus, then in the next case then we're going to have t is going to be 0 and sine on top is going to be sine 0, which comes to 0, so the whole second bracket will come to 0, which makes life easy. And now we'll figure out sine 2000 pi, so we can put that into the calculator. Put the calculator to rads and get sine 2000 pi, and that's 0 as well. So a lot of this stuff here, this all becomes 0, so we'll end up with 15. Oh, pen has gone nuts here. 1 second now. Undo that. Right, so we have 15.625 multiplied by 20. Right, so 15.625 multiplied by 20 gives us 312.5. So that's the average value between those limits of y squared. And now we just one step remaining to get the root mean square. We take the square root of that value, 312.5. We get the square root of that. I get 17. Oh, he wants it to 4 significant figures, so 17.68. 17.68, and it's gonna be volts, so we'll stick in a V.